So let's talk about variables and equations. So we know that the difference in an equation and an expression is that an equation has an equal sign, meaning 9 plus 2 equals 11, right? 9 plus 2 would just be an expression. So up here is our equation, down here is our expression. Yeah? Okay. But now let's throw a variable in that. Let's say x plus 5 equals 12. Now we have a variable equation because we have that equal sign, which makes it an equation, and we have that variable, which makes it a variable equation. The solution of an equation would be whatever value for that variable that makes the equation true. Meaning, what value would I need to put in for x so that x plus 5 equals 12? Now you guys could probably do that in your heads because it's pretty simple if you just kind of look at it for a second. You have to say, okay, guess and check, it's 9, no that doesn't work, it's 8, getting close, 7, yeah. If I put in 7 right here, 7 plus 5 is 12. So we know that x equals 7, right? Now what we're going to work on is how to actually get to that mathematically. When solving equations, it's important to think that you always have to do the order of operations but backwards. Meaning, we know that with order of operations we go grouping, symbols, exponents, multiplication, division, addition, and subtraction. When we're solving, since we're working backwards, we need to go backwards, which means we would do subtraction, then addition, then our division and multiplication, exponents, and then grouping symbols. Of course, we still go left to right with the multiplication, division, and all that. But we have to go backwards. So in this equation, I've given you a pretty simple one. A lot of people find it helpful to draw that line all the way down so we know that that's like our equal sign coming down. We only have one step to solve this equation. It says x plus 8. Well, if I want to know what x is, so I've got to get x all by itself. If it says plus 8, I need to do the opposite in order to get rid of that because it says x and 8 more, so if I want x by itself, I need to take away that 8. So I say subtract 8. If I subtract 8 there, that would mean that 8, positive 8 minus 8 would be 0. But if I did it to one side, I have to do it to the other. So now, down here, I've got x equals, now 14 minus 8 is what? Is it 2, 3, 20, what? Awesome, it's 6. Now, you can always go back and check yourself. This is the beauty of variables and equations. Take that number and plug it back in, meaning do 6 plus 8 equals 14. 6 plus 8 is 14, so therefore 14 equals 14, and we know that yes, that did work, so x does equal 6. Let's do another now with multiplication. So I'm going to draw that line down the middle again because a lot of you are going to find that helpful. So this says 3x. What does 3x actually mean? That's like saying 3 times x, right? Well, again, like I said, you need to do the opposite. So if that says 3 times x and I want to get x all by itself, let's think about that. It means I started with x and I made it 3 times as big. So if it's 3 times as big, how do I get it back to itself? I need to divide it up by 3. Now that's a fraction bar there, which means like 3 divided by 3, which is 1. This will leave me with x all by itself. If I divide it by 3 on the left, I need to do it to both sides. 15 divided by 3 is 5. Awesome. Okay, now, like I said before, check yourself. So 3 times 5 equals 15. Well, does 3 times 5 equal 15? Yes. Awesome. Okay, so let's do another one here now. I'm going to give you a couple of steps. That way we get a little bit more of a challenge and make sure we've got this. So again, I'm going to draw that line all the way down. Now, like I said before, when we're doing the order of operations and we go backwards, this says 4 times x minus 6. Now, normally we would say 4 times x comes first, and then we would subtract 6. But we're going to go backwards. So if this says subtract 6, I'm going to add 6 to both sides. What does that leave me left with on the left side? I have 4x equals, now 14 plus 6 is 20. Okay. Last step, this says 4 times x, so to get rid of it, I would divide by 4, and I would get x equals, it's a tough one, 5. And I can go back and check. Let's try it. 4 times 5 minus 6 equals 14. Sorry, I'm running out of space a little bit. 4 times 5 is 20, minus 6 equals 14. Is that true? Yes, awesome. For this last example, I'm going to show you two different ways of solving it. First one's going to be the more drawn out way, and the second way is going to be a little bit faster. The first way, though, is going to be more of showing you the process and making sure you understand not only how to solve equations, but that also you understand the distributive property. So let's look here first, and we would say that x plus 3, we cannot combine anything with that, because 3 plus x is not 3x, it's just x plus 3. Now we have this 4 right here, and then it's attached to what's inside the parentheses, which is x plus 3. So using the distributive property, I could say 4 times x and 4 times 3. Well, 4 times x, that's 4x, because that's the same thing as 4 times x, which is 4x. Plus, because that's the sign that was in there, 4 times 3. What is 4 times 3? You know what? I'll just go ahead and write it out like this. Now, I say 4 times x is 4x, plus what's 4 times 3? 12. So, now I've got 4x plus 12 equals 24. Now, order of operations says multiplication comes before addition, but since we're working backwards, I need to actually do addition before my multiplication to get rid of it. So I've got plus 12. So the way to get rid of a plus 12 is to say minus 12. That cancels each other out. Again, I have to do the same thing to both sides. Now, when I subtract 12 from 12, I'm left with 4x equals, now I have 24 minus 12. What's 24 minus 12? Awesome. Now, I've got 4 times x. To get rid of that 4 times x, as in I want x all by itself. 4 times x means 4 times x. The opposite of multiplying is dividing. So I divide both of them. That'll leave me with x equals what? What's 12 divided by 4? 1, 2, 3, 4. Oh yeah, it's 3. Okay. So we have x equals 3. Now, what I want you to do is to go back and check to make sure that's correct. So, again, I would write 4, and then I would say 3 plus 3 equals 24. For this, I'm going to actually combine what's inside the parentheses first and say that 3 plus 3, which is 6. So I'm going to say 4 times 6 equals 24. Well, does it? What's 4 times 6? I think it's like something around 22, 23, 20. Yeah, it's 24. So we know that 24 equals 24. Awesome. So this next way is a little bit faster in that I'm not going to actually distribute the 4 and multiply and add and then subtract and go all that. What I'm going to do is know that since it was already saying 4 times everything that's inside of here, I'm going to go ahead and start by eliminating that 4. This, like I said, means 4 times all of that. Well, how do I undo 4 times anything? I would divide by 4. That gets rid of that 4 right off the bat. But in order to do so, I need to do the same thing to both sides. Now, when I divide by 4, that 4 cancels out the other 4 on the top, meaning that my numerator and denominator 4s cancel each other out. So now I've got what's left there is x plus 3 equals, and then I've got 24 divided by 4. Let me check my fingers real quick. I think 6. Okay. Now, I've got only thing left is x plus 3. The opposite of plus 3 is to say minus 3. And if I do that to both sides, so it leaves me with x equals, and then what's 6 minus 3? 3. Now, was that the same answer? Yes, it was. So therefore, I'm not going to go back and check it all again, but it shows you that I did get the same thing going just a little bit faster.